Okay, so let's have a look at example 6. There's a few, you've got to get used to the language and understand what happens by default. Okay, so the scores in example 6, scores marked out of 10 for a class of students in English and TOK or blah. Okay, so you should be able to see that. I'm not going to bore you by typing that data in again, so it's already typed in. So it's find the regression equation of y on x. That is the standard linear regression and done by default. Okay, so when we put our information into the GDC, it will always give us a y on x regression by default. Okay, so I type the data in. Like everything on this calculator, if you press menu, statistics, stat calc, I can show you that both of these are exactly the same, but I advise you to go and do this yourself. Okay, so you could choose number 3 or number 4. You just have to be aware that the letters change slightly. Okay. I'm going to stick with mx plus b because that's how we recognize it. Okay, so where is our x data? Our x data is English, our y data is TOK. And where do we want our first result column? We want it in column C, please. Okay, so that tells us that we have a gradient of 0.764 and an intercept of 1.92 with an R squared, a coefficient of determination of 0.689, which is strong, and then we've got an R value of 0.82830. So when we plot this, we're expecting to see a fairly strong increasing line. Okay, so solution is y equals, so part A, the regression equation is y equals 0.764x plus 1.92. Then it says find the regression of x on y. Okay, so this time it's exactly the same. Menu, statistics, stat calc, linear regression. I'm going to stick with mx plus b. But this time, because we're doing x on y, we now have to flip the data. So it might be that our English data was our x data, but now we're trying to minimize the error in the y. So we're going to go, in the x. So we'll go TOK, and our y data now is English. Okay, so let's go and we want our, E is perfectly okay. And this tells us now that we have a regression, so linear regression of x on y of y equals 0.902 x plus 0.139. Okay, with an R squared, the R squareds are exactly, R squared and R are exactly the same, okay, because it's the same data set. All we're doing is shifting how we look at it. Show both lines on a scatter plot with the English score on the horizontal axis, okay. So I'm not going to plot it by hand. I'm going to use the GDC. So let's go to add a document. Let's add data and statistics. And we need to put English on this value, and we need to put TOK on that one. Okay, so that's pretty much what we were expecting to see. A fairly nice line. Okay, so let's work out the regression again. Menu, analyze graph. We want to do regression. Okay, so we're doing regression of show linear. Done. Okay, so those are our values again, 0.764x plus 1.92. So that will minimize the error in the TOK if we have an English result. Okay, so find the predicted TOK score to the nearest whole number for a student who scores 9 in English. So 9 in English, going to go up and across. It looks like they're probably going to be scoring a 9. Yeah, so going for the nearest value that looks like a 9 and a 9 using that regression line. Then it says find the predicted English score to the nearest whole number for a student who scores 8 in TOK. Right, so now we can't just go 8 across and down because there's too much error this way. So what we need to do now is we need to click here and we need to stick English over. You'll notice that this switches and the regression line has also switched to 0.902x plus 1.0. So we've now minimized the error in this axis. So if they scored an 8 in TOK, we're going to go up and across. It looks like it's going to be about is that a 7? It's possibly a 7 in English. Yeah, so you can be much more accurate here by if we substitute 8 into this value and do 0.9016 blah 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 times by 8, add that, that's going to give us a better value than just eyeballing it. So the expectation would be that you substitute a value into here to get your value out. But notice when we did an X on Y regression, originally our independent variable English becomes our output to minimize the error in the Y.